How's it, grade 11? So we're continuing with differentiation. I'm now moving on to the chapter differentiation using rules. Okay, so as you learned with this chapter over here, differentiating using first principles, you found the derivative, okay, and you found the derivative using first principles. What we can do is we can use a quick way for finding these derivatives, and these are some of the rules over here that we're going to be going through. Okay, so don't worry about what these say just yet. I will go through examples and show you how to do it. What I do want you to take note of is the product rule, the quotient rule, and the chain rule. Okay, those are three methods that will help us differentiate certain functions, and we'll get to it in a second. Okay, so don't worry too much about the notation. Much easier to go through an example, and I can show you how to do these. Okay, now also just to keep in mind, how do you know when to use this quick way or first principles? Because with first principles, they will tell you by the H method or by first principles, that type of thing. When they just say differentiate, then you can use the quick way, which we'll go through to today. Okay, also just a couple of other things that I want to go through. If they're given it to you in the form y equals, okay, whatever your function y is equal to, you must give your derivative as dy dx equals, okay, so the original function, the derivative function. If they give it to you in functional notation, say f of x or g of x or h of x, then you must say f dashed of x equals. So the derivative, the original. Then if they give it to you in a weird way like this, either saying like dx of something, here you can go straight into just saying the derivative. We don't have to write anything there. And then another way they do it is they'll probably say d by dx of something equals, and we just write the derivative. Okay, so now this d by dx could be d by dt, d by dy, d by dp, whatever the case is. It's just saying differentiate this thing with respect to x, or differentiate this thing with respect to t, whatever that letter is over there. That's what this means here as well. dx of whatever, differentiate this thing with respect to x. Okay, so if we go through example 1, and guys, I will show you how to pick up which one to use, either like the product rule, the chain rule, or the quotient rule. Okay, so if we look at question A, they're asking us to find the derivative of y is equal to x to the 6 minus 4x to the 4 plus 4x squared. Now, this is generally how you want your function to be, like a polynomial. Okay, because it's so much easier to differentiate this. And what we're going to do is we're going to differentiate each term separately. Okay, so as you can see here, we have three terms. We've got this x to the 6. We've got this minus 4x to the 4. And we've got this plus 4x squared. So when we have different terms like that, we can differentiate them separately. And now how do we do it the quick way? Well, the coefficient of this one over here, there's an invisible 1. So let me just put that in another color. So we've got an invisible 1 then. So I'm ready to differentiate. So we go dy dx. Remember, if it's the function y, the derivative is dy dx, saying we're differentiating y with respect to x. Okay, so I take the exponent and I multiply it with the front. 6 times 1 gives me 6x, and I decrease that power by 1. And that is the derivative of this thing. And you can even test it. If you find the derivative of this using first principles, you will get this. Okay, now moving on to this one over here. Exactly the same thing, guys. Take the power, multiply it with the coefficient. So 4 times minus 4 is minus 16. X to the decrease the power by 1, and we get 3. Moving on to this one, the exponent times the coefficient, so that's going to give us plus 8. x to the power of 1. Okay, and that is our derivative right there. Going on to question B, we've got y is equal to 3 over x squared minus 2 over x plus 3. Now, this is not in a polynomial form like it was with this original one. The reason why is because we've got these variables in the denominator. So what I'm going to do is I'm just going to bring them to the top. And you remember, if I bring them to the top, the exponent changes its sign. So I am not taking the derivative yet. So this is y is equal to 3x to the minus 2 minus 2x to the minus 1 plus 3. Okay, and I didn't take the derivative, so I left it as y. Now what we've got is we've got a very similar situation like this one here. We've got 3 terms. We've got that one there. We've got that one there. And we've got this one over here. All right, so the method is we take the exponent times the coefficient. So minus 2 times 3 is minus 6. X to the, decrease that power by 1, so it's minus 3. Minus 1 times minus 2 is plus 2x, decrease that power by 1. Now, this one over here, guys, it does have an x, okay? And its x power is 0. Also, the derivative, so we can just put here x to the power of 0, okay? Now, this is a constant. The derivative of a constant is 0. So this would just be, and I'm going to put it in another color because we don't have to put it there, it's plus 0. And if you have a look here at one of your rules, what this very first one is saying, it's saying the derivative of k, now remember k is a constant, whatever number, the derivative of a number with respect to x is 0. Now why is that? Is because if I had to draw up a graph, and let's say that I want to draw the graph y is equal to 3. Okay, so there's my graph y is equal to 3. Now remember what the derivative is finding. The derivative is finding the gradient of something. Okay, so in other words, this minus 6x to the minus 3 is the gradient for that one. 2x to the minus 2 is the gradient for that one. And 0 is the gradient for this one. And you can see, you know that the gradient for a straight or a horizontal straight line is 0. Okay, and that's why it's 0 there. Now, we never write things with, sorry, this is dy dx here. We never write things with negative exponents. I must just write this as positive exponents. So this would be minus 6 over x cubed plus 2 over x squared. And that is your final answer. Okay, going on to example C. Example C, we've got k of x. Sorry, that was another exercise. Example C is y is equal to the root of x minus 2 over the root of x minus 1 over 3, the cube root of x. Okay, now what I want to do is I want to get rid of these surds. Okay, and we're going to use one of our exponential laws. You know, when you've got a to the m to the nth root, that will be equal to a to the m over n. That's all I'm going to do here. So I'm not finding the derivative just yet. So this would be x to the half minus 2 over x to the half again minus 1 over 3 x to the 1 over 3. Okay, I'm going to bring this one to the top, and I'm just going to bring this x to the top. I don't care about the 3. Okay, so very similar to what I did over here. I brought the x squared to the top, the x to the top. Okay, So we get here y is equal to x to the half minus 2x to the minus a half minus 1 over 3 x to the minus 1 over 3. Now, the reason why I'm not bringing the 3 to the top with this is because we're not differentiating with respect to 3. We're differentiating with respect to x. Now that I have it in a polynomial form, I have that as a term, that as a term, and that as a term. I can differentiate them separately. So dy dx is equal to, now the derivative of this one, remember that the coefficient over here, there's an invisible 1. A half times 1 is a half. X to the, decrease this by 1 and we get minus a half. Okay, minus a half times 2 is plus 1. Decrease that by 1 and we get minus 3 over 2. Then a third, or sorry, negative a third times negative a third times negative a third is plus 1 over 9. X to the, decrease that by 1 and we get minus 4 over 3. Okay, that is our derivative, but we don't write, or we don't leave it with negative exponents. So I'm just going to rewrite it with positive exponents. So dy dx is equal to, this one comes to the bottom, so it's 1 over 2 x to the half, plus this one goes to the bottom because it's negative 3 over 2, plus this one goes to the bottom because it's negative 1 over 9 x 4 over 3. And those answers are fine, guys. You don't need to put them back into surd form like this. Okay, so there's our final answer. Then question D. We've got y is equal to x to the 7 minus 4 over 4x to the 3. Now, this would be a candidate to be using the quotient rule, okay? Where you can see over here, the quotient rule is saying if you've got something, a function over a function, okay? But this question is specifically telling us without applying the quotient rule, okay? So I'm not going to use the quotient rule for this one. So what we would do in a situation like this, especially when you have a single denominator. Grade 11s, please take note of that, a single denominator, because I will go through an example later where we don't have a single denominator. We have something like 2 terms or 3 terms, okay? Just a single term. What we can do here is we can make our lives a little bit easier and try and avoid using the quotient rule because it's quite a lengthy method and you could possibly make a mistake. So if there is a single term in the denominator, what I want you guys to do is split it. And how we're going to split it is it's going to be x to the 7 over 4x cubed minus 4 over 4x cubed. And that's what I mean by splitting it. Okay, you guys agree that this will be that. So what I'm going to do now is just simplify things. So we get y is equal to, these 3 x's will cancel with 3 x's there, and we're left with x to the 4. And this is over 4. Those 4's will cancel, and I'm just going to bring the x to the top, so we'll get x to the minus 3. All right, now we're ready to differentiate because we have a single term and a single term, and we differentiate them separately. So dy dx is equal to, multiply the exponent with the front, so there's 1 there, so 4 times 1 is 4, but then those 4's cancel. Decrease the power by 1, so we're left with x to the power of 3. Minus 3 times minus 1 is plus 3. X, decrease that power by 1, which is minus 4. We don't write with negative exponents, so it's dy dx is equal to x cubed plus 3 over x to the 4. And that is that, guys. So what I would like you to do to practice this one is You can start with exercise 1. You can try these ones over here for me. All right, guys. I'll be making another video for you now.